Have you ever wondered how we measure the size or length of a vector? It's a fundamental question that arises in various fields, from computer graphics to physics simulations. In mathematics, we use something called and today, I'm going to break it down for you. We'll explore what vector norms are, how they work, and why they're so incredibly useful. So, whether you're deep into linear algebra, tackling complex equations, or just dipping your toes into the world of math, perhaps exploring introductory concepts, the concept of a vector norm is absolutely fundamental. It's a building block upon which many other mathematical ideas are constructed. Let's explore what it is, why it matters, diving into its significance, and how you'll see it pop up everywhere, from the algorithms that power your favorite apps to the simulations that predict the weather. Alright, here's the core idea. A is just a function that takes in a vector as its input, and spits out a non-negative number as its output. This number represents the size or length of that vector. It gives us a way to quantify how big the vector is. The most common one you'll hear about is sometimes called it's a fundamental concept in Euclidean space. If you've ever used the Pythagorean theorem to calculate the hypotenuse of a right triangle, you already know the basics. The 2 norm is essentially an extension of the Pythagorean theorem to higher dimensions. For a vector with components v1, v2 all the way up to vn, representing its coordinates in n-dimensional space, the 2 norm is calculated by taking the square root of the sum of the squares of its components. We square each component, add them all together, and then take the square root of the result. Mathematically, that's written as v plus equal sign, v12 plus v22 plus vn2. This formula might look intimidating at first, but it's really just a concise way of expressing the Pythagorean theorem in n dimensions. But the 2 norm is just one type. There's also where you simply add up the absolute values of each component. This norm is also known as the Manhattan distance or the taxicab norm. One equal sign v1 plus v2 plus vn plus. Instead of squaring the components, we take their absolute values, ensuring that each component contributes positively to the overall norm. And then that's the biggest absolute value out of all the components. This norm focuses on the component with the largest magnitude, effectively ignoring the smaller components. Pretty neat, right? Norms aren't just about numbers, they're a way to, and vectors. Think arrows in space, visualizing them as directed line segments, each with its own length pointing in different directions. Norms provide a consistent way to measure and compare these vectors, regardless of their orientation. So why do norms matter? They help us measure distance, providing a way to quantify the separation between points in space, compare vectors, allowing us to determine which vector is larger or more significant, and solve real-world problems in things like optimization and machine learning. They are essential for training machine learning models and finding optimal solutions to complex problems. Understanding norms gives you a powerful tool, not just in math class where you'll encounter them in linear algebra and calculus, but in science, engineering, and beyond. They are used in fields ranging from physics to finance. If you found this helpful, don't forget to like this video and follow for more math insights. Your support helps us create more educational content. Thanks for watching. We hope you now have a better understanding of vector norms and their importance.